Louis de Broglie in the 1920s came up with a bold suggestion on his PhD thesis. This is the idea of wave-particle duality. If wave-like light can show particle properties, particles like electrons should show wave-like properties, which sounds like a relatively simple idea. The de Broglie equation relates wave properly to a moving particle, momentum, and Planck's constant. So it's lambda equals h over mv. Now, the de Broglie wave of particle can be interpreted as a probability wave, which is basically the idea of finding a particle at a point is directly proportional to the square of the amplitude of the wave at that point, even though this is really relevant for any A-level syllabus. Many physicists did not believe this at the time because this was a speculative idea. However, once electron diffraction was discovered, people began to think that his ideas had more merit to them. Electron diffraction shows the wave nature of an electron. So in the same way, the photoelectric effect shows the particle nature of light. Diffraction patterns are observed when accelerated electrons in a vacuum tube interact by the spaces in a graphite crystal. This shows that they have wave-like properties. According to wave theory, the spread of lines of the diffraction pattern increase if the wavelength is greater. The idea is to use a smaller accelerating voltage so the electrons are slower, so they give widely spaced rings, increase the electron speed, and the momentum of the diffraction pattern squashes together. This fits with the equation as if the momentum is greater, the wavelength is shorter, and the spread is smaller. So in general, the electrons in a vacuum tube are the same size as the electromagnetic waves in the X-ray part of the spectrum. Now, if particles with greater mass were travelling at the same speed, they would show a more tightly packed diffraction pattern. This is because their mass and momentum would be much greater, and therefore would have a shorter de Broglie's wavelength. Particles don't show wave-like properties all the time, and you would only get it if the diffraction occurred with an object that was around the same size of its de Broglie's wavelength. Anyway, de Broglie's theory wasn't accepted straight away, and it wasn't until other scientists evaluated it and peer-reviewed it and tested it that actually it was considered to be a good idea, and it was validated by the scientific community.